We've learned how to find intercepts from a graph. Now we're going to learn how to find intercepts from a table. This says a swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool and the time in hours that the pool has been draining. And our first task is to find the x and y intercepts. All you have to remember to find the x and y intercepts is that the y-intercept is where x equals 0. So the y-intercept is always going to be 0 and then whatever the y-coordinate is. Every y-intercept looks like that, 0, comma, something. And then the x-intercept, of course, is exactly the opposite. The x-intercept is where y equals 0. So the x-intercept is always going to be whatever the x-coordinate is, 0. And if we look at our table is very helpful about finding the x and y intercepts. Here's our x column, and here is the spot where x equals 0. That very first row in our table is 0, 10,880. That is our y-intercept. It's the spot where x equals 0. The y-intercept is 0, 10,080. I think I said 880. That's not right. It's 10,080. And then if you go down to the very bottom row, that's where y equals 0. There's our x-intercept. Our x-intercept is 14, 0. Now our next task is to graph the function. And since this is being drained at a constant rate, 720, a constant rate means that this graph is going to be linear. It's going to be a straight line. Anytime we have something that's a straight line, we can graph it with only 2 points. So to graph it, we just need to put our y-intercept and our x-intercept on our graph and then connect those 2 dots. So when I draw my graph, I'm going to just do a very quick sketch here. I need my y-axis to go up to at least 10,000, and I need my x-axis to go to at least 14. Now, it doesn't have to be to scale. Thank goodness. It doesn't have to be to scale. The same scale, because I don't want my x to go by ones up to 14 and then my y to go up by ones up to 10,000. That would be crazy. Let's go ahead and label it though. It says our x is time in hours and our y is volume in gallons. So I'm going to go ahead and label this. This is going to be time in hours. And our y is going to be volume in gallons. Okay. And then I just need the time to go up to 14, and I'm going to be real sloppy with my graph here because I just need a sketch. I'm just going to say this is 14, so like halfway in between would be 7. And I know my x-intercept is going to be right here. And then on the y-axis, 10,080 is going to be a little bit higher than 10,000. So there's 10,000. 5,000. Oops. I'm just going to put 5K because I don't have quite enough space there. 5K is going to be right in the middle. And my 10,080 is just going to be very, very slightly above 10,000. I'm not going to bother doing all of the marks in between. This is good enough. This gets the point across of where the intercepts are. I'm not going to spend a whole bunch of time measuring out and doing a whole bunch of marks. This is perfectly acceptable for graphing. Now, if I had an actual grid here, obviously I would use the actual grid, but this is good enough. Now, one thing I want to make sure of is that I do not go into the negatives because it would not make sense for me to have a negative number of gallons or a negative number of hours. So I am going to erase those marks where I went a little past the axes. I want this to just be positive numbers just up in the first quadrant. That's why I only drew the first quadrant. But now that we've got this done, perfect. We identified the x and y intercepts, and then we used those x and y intercepts to sketch the graph.